Welcome back to Shiksha DaCosta. Today we are doing C2.1, the primary trig ratios. And this is part of learning how to apply the sine law and the cosine law in acute triangles. So today we're learning about the primary trig ratios, sine, cosine, and tangent, and we're going to learn how to use them to solve real-world problems. You're successful, of course, when you can solve problems, including those that arise from real-world applications, by determining the measures of the sides and of the angles of right triangles. And you'll do that using the primary trig ratios.
Okay, so I'll ask you to take just 1 minute to see if you can figure out what is the length of the hypotenuse, what is the length of the side that is opposite the angle theta. This symbol here is a Greek letter. It's called theta. So what side is opposite this angle, and what side is adjacent to this angle? And the word adjacent here means right next to. So what side is next to it, but not the hypotenuse? Which side is the hypotenuse, and which side is opposite the angle? And figure out what those lengths are. And in 1 minute, I'll ask you about that. So hopefully that minute was good for you. For this triangle, well, if this is the angle, the easiest one to determine, of course, is the opposite side. Or actually, sorry, I guess the easiest one would be the hypotenuse, right? That's the longest side in the triangle. So if this is the hypotenuse, the side that's opposite this angle is going to be a side that isn't touching it. So this side is touching this angle. This side is touching this angle. So this must be the opposite. So the opposite must be 1 centimeter. If this is the hypotenuse, then this side must be adjacent. And remember, adjacent means right next to, right? And this side is right next to this angle. So that must be the adjacent side. And finally, the hypotenuse is this one right here. So that's pretty easy to do, right? And in this triangle, let's do the same thing, but instead of figuring out the hypotenuse first, let's see if we can just go in order. So what side is opposite? Oh, it must be this side because it's the only one that's not touching. That's 2 centimeters. What side is adjacent? Well, this side is touching it, and this side is touching it. So how do I decide which one is which? Well, this one is the hypotenuse, obviously. So this side is the adjacent side at 3.46, and this side is the hypotenuse at 4 centimeters. The next question I'm going to ask you is determine the ratios listed here for each triangle. So if I took the opposite side and I divided it by the hypotenuse, what number would I get? If I took the adjacent side and divided it by the hypotenuse, what number would I get there? And finally, if I took the opposite side and divided it by the adjacent side, what number would I get there? Take another 90 seconds to see if you can figure this one out for both triangles. So hopefully that was enough time. If not, take another 90 seconds to yourself, of course. And before I take these up, I want to point out a couple things that you may have noticed. This triangle and this triangle seem to have some similarities. Well, this is 1 centimeter. This is 2 centimeters, twice as big. This is 2 centimeters. This is 4 centimeters, twice as big. This is 1.73. This is 3.46. And it's not easy to notice, but that is 2 times what this is. They both have the same 90-degree angle. And so this angle is probably the same as well. So these are called similar triangles, not congruent because they are different sizes, but similar in that their angles are all the same. And now when we look at the ratios, if I take the opposite divided by the hypotenuse, 1 divided by 2, 0.5, easy. Adjacent divided by hypotenuse, 1.73 divided by 2, 0.865. And finally, opposite divided by adjacent, that's 1 divided by 1.73, is a much longer number, 0.578, but this is all we'll keep it to for now. Now let's go to the other triangle. Again, I'm dividing the same sides, right? Over here, I did opposite over hypotenuse. So I did opposite divided by hypotenuse, so 1 divided by 2. But in this triangle, I'll do opposite divided by hypotenuse. That's 2 divided by 4. And what do you know? I still get 0.5. If I do the adjacent divided by the hypotenuse, that's 3.46 divided by 4, I still get 0.865. And finally, when I do opposite divided by adjacent, I still get 0.578. How strange. So what do you notice about these two? Well, for similar right triangles, right, no matter how big the triangles are, if the angles are the same, so if those triangles are similar, then the ratios of the corresponding side lengths are always going to be the same. So if I'm choosing this angle, and this is very important, it's not just any, I can't choose this angle on this triangle and this angle on this triangle. I have to choose the same angle in both triangles. So if I have a right triangle and I choose this, and they are similar, and I choose the same angle in both, the ratios of the sides will always be the same. So opposite divided by hypotenuse was 0.5 in both triangles. If I take the adjacent and divide it by the hypotenuse, that was 0.865 in both triangles. And these ratios have special names. Opposite over hypotenuse is a lot of, mouth energy to use. It's a lot of syllables. It's long words. Instead, they call this sine. So sine theta, so sine of some angle, is the ratio of the side opposite it divided by the hypotenuse. That's all that sine theta means. It means take the opposite side and divide it by the hypotenuse. This is cosine of theta. And what that means is when you see cosine theta, it means look at angle theta and then divide the adjacent side, the side that is adjacent to theta, by the hypotenuse. And finally, tan theta. Tan theta means look at theta and then divide the side that's opposite it to the side that is adjacent to it.
So where would we use this stuff in the real world? For example, if you were making your own card game, like Klaus. Klaus is making his own card game, and the boxes that he ordered to keep all of his cards in are 9 centimeters wide and 4 centimeters tall. But the cards that he makes are actually a little bit bigger. They're 9 centimeters by 6 centimeters. So that extra little 2 centimeters is going to stick out of the box if he puts all of the cards in there. And obviously, he's not a fan of that, right? So what Klaus decides to do is he puts them in at an angle. So he creates this little triangular block, and he puts this at the back of the box, and then all the cards can lie at an angle, so they're not as tall. And that's sort of what that looks like, right? So here's the triangular block. You can see that the cards, even though the card is 6 centimeters wide, that 6 centimeters is at an angle, and the height of this wooden block is 4 centimeters. So we can actually put that wooden block right over here at the back of his box. And so it will fit the height of the box. The cards will all fit because they'll be at an angle. But the problem is, Klaus now needs to know what is the angle that he should cut his block at. What is this angle supposed to be? So that the top of the cards is actually at the top of the box and not sticking out like this. Trig ratios can help us solve problems like this. So in this case, we're looking to find out what is theta. What is this angle? Now we know that the side opposite it is 4 centimeters. We know that the hypotenuse is 6 centimeters. So there is a ratio that we can use that relates these three variables, and that is the sine ratio. Remember, the sine ratio will always tell you what is the opposite divided by the hypotenuse for any angle. So sine theta is opposite over hypotenuse, and I know that the opposite side is 4 centimeters. The hypotenuse is 6 centimeters. How does that help me find out what theta itself is? Well, we're actually going to get into this after we take this up, but after we summarize these concepts. But for every operation, there's always an inverse operation. And the primary trig ratios have inverse operations, and that's what they look like. Again, we'll go into more detail in that in just a minute. And what this does is, just like the inverse of multiplication is division, and just like the inverse of addition is subtraction, these two will cancel each other out, just like multiplication would cancel out division. And now we're left with theta all by itself. We just have to do the same thing to the other side, right? Because whatever you do to one side of an equation, you have to do to the other. And now we will find out that on the left side, theta is just by itself. And if you were to put this into a calculator, remember the calculator knows that, okay, if the ratio is 4 and 4 over 6, and we're talking about the sine ratio, then there's only one angle that could create this. And that angle, your calculator will tell you, is about 41.81 degrees, or about 42 degrees. So that's helpful for Klaus, right? He knows I can cut my block of wood at a 42-degree angle down here, and that way the hypotenuse, or this side of the block, will be 6 centimeters, so the card will fit perfectly, and this side will be 4 centimeters, so the block of wood will fit perfectly inside his box of his card game, Heroes of Tirana.
And that's all this lesson is, right? In a triangle, depending on which angle you choose, you can find out the value of the three primary trig ratios. The first trig ratio is sine. That is the ratio of the side opposite the angle to the hypotenuse. The second one is cosine. That's the ratio of the side adjacent to the angle to the hypotenuse. And the last one is tangent, and that is the ratio of the side opposite the angle to the side that is adjacent to it. So here's your quick little formula. Sine of x, where x is whatever the angle is equal to opposite over hypotenuse. Cosine of x is adjacent over hypotenuse, and tan of x is opposite over adjacent. An easy way to remember this little formula: so S O H ka C A H toa T O A. SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. So if you need to solve a right triangle, you first find out which two side lengths are you comparing. So if you're comparing the adjacent side to the hypotenuse, well, which of these three has an A and an H in it? Only this one. So that means you need to use cosine. And so on for sine and tan. The last little bit here is, if you already have the ratio, so if you know what this number is after you divide it, you can use what's called the inverse of the function. And on your calculator, you'll see something that looks kind of like this. You can use that inverse function to go backwards. So you can go from the ratio to find out what the angle is. So usually on your calculator, you'll have a shift key or a second button, and then you'll just use the regular sine, cos, and tan buttons to evaluate it. Let's do some examples. So in this triangle, this is a right angle. D to F is 13.4 centimeters, and angle F is 33 degrees. What is the length of DE? Well, this question involves an angle, the side that is opposite the angle, right? That's DE, and the hypotenuse. Okay, so if I'm trying to use the opposite and the hypotenuse in my question, which ratio do you think I have to use? If you guessed sine, you're correct, right? SOH. Sine of an angle equals the opposite side, which we don't know yet, divided by the hypotenuse. So I have an equation, and now that I have an equation, I can use my regular rules of algebra to find out what x is. I want to get rid of 13.4, so I will multiply it, because right now it's being divided. That will cancel it out, and then I have to do the same thing to the other side, multiply it by 13.4. And I can plug this into my calculator and find out that this is equal to 7.2982.
Find the measure of side B to the nearest meter. Okay, so let's see. Side B, well, this is angle B, and side B would be directly opposite it. Usually in a triangle, the side with the same letter is opposite the angle that has the same letter. So this is side B over here, right? In my equation, I will have an angle. I will have the side length that is adjacent to the angle. And since I'll be working with adjacent and hypotenuse means I need to use cosine. Cosine of A, so cosine of this angle is equal to the adjacent side divided by the hypotenuse. And that angle is 28, the adjacent side is 16, divided by the hypotenuse, which is side B. We don't know what B is, but we're trying to find out what it is. And that means we just need to isolate it. The first step on that process is to get it out of the denominator. So I'll multiply this side by b, and that will get rid of b in the denominator. And I have to do the same thing to the other side. I'll multiply this all by b. So I'm left with b times cosine 28 on the left side, and 16 all by itself on the right side. Now remember, I want to get b all by itself, so I will get rid of this operation, multiplication by cos 28. I'll get rid of it by dividing. And then I just do the same thing to the right side, 16 divided by cos 28. And that tells me that b, because now b is all by itself, b is equal to 16 divided by cos 28, which I can put into my calculator and find out that it's approximately 18.12112, or about 18 meters.
Example 3, find the measure of angle A. So in this case, I'm not looking for a side length. I'm actually looking for the angle. So here is angle A. I have the opposite side. I have the hypotenuse, which means I need to be using sine. So sine of angle A is equal to opposite over hypotenuse. And when I divide these two, I would get 0.5 or something, but I'll leave it the way it is right now. The point is here, I want to get A by itself. So we know that when we are isolating, and we talked about this earlier in this lesson, the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. The opposite of division is multiplication. Some of the other ones we might notice is like the opposite of a square is a square root, and vice versa. But what is the opposite of sine? Well, it is, like we mentioned in summary, the sine inverse. And the opposite of cosine is the cosine inverse. And finally, for tan, it's the tan inverse. And so to get rid of the operation, and we want to get rid of the operation sine here, don't we? What I'm going to do is do the sine inverse, and just like multiplication and division cancel each other out, these two will cancel each other out. But whatever I do to one side, I have to do to the other side. So when I do the sine inverse of this, and you can test it out for yourself on your calculator, you should end up with exactly 30 degrees.
At what angle, theta, should a carpenter cut the wooden beam below, this one right here, to shape it so that they can create a roof truss? and let's round that to the nearest tenth. So we're trying to find out what is this angle over here, because it's the same one over here, and the carpenter needs to cut it to be able to have this wood beam support the roof properly. So what I can do is I can make a triangle here. I can make a triangle going from here down here, and then all the way across to here. And I know the measurements of this triangle, right? I know that the height of this triangle is 4.3, and the width is, notice this roof is split into half. So if the full roof is 6.4 meters wide, half of it will be 3.2 meters, just divided by 2. And now that I know the side lengths of this triangle, I can use them, or the ratio between them, to find out what is this angle. I'm going to use tan because I have the side opposite this angle, and I have the side that is adjacent to the angle. I don't have the hypotenuse, so I can't use sine, I can't use cosine, I have to use tan. So tan of that angle is going to equal 4.3 divided by 3.2, which is about 1.34375. So that is the ratio between these two. The next thing I can do is I can say, okay, well, I want to get rid of tan just to get, I want theta all by itself. That's what I'm trying to find out. So I'll do the inverse tan operation, which will cancel it out. And then I do the inverse to the right side as well. And that tells me that theta is equal to 53.343 degrees. And of course, I need to round this to the nearest tenth, which is 1 decimal place. And so that would just be 53.3, because the next number is less than 5. If you enjoyed this video, please like, rate, subscribe, and join our mailing list. You can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks, and have a great day.